So a car is driving at 20 meters per second, and after 10 seconds, its speed is 50 meters per second. How far does it travel in this time? What is its rate of acceleration? First thing I'm going to do, I'm going to write down Suvat and see what variables we know. Okay, so how far does it travel in this time? So we don't know that yet. So displacement, we're not sure. It's driving at 20 meters per second, and then after 10 seconds, its speed is 50 meters per second. So the initial velocity must be 20 meters per second, and then the final must be 50 meters per second. So then t we'll just set equal to 10 seconds. 10 seconds there, and then also we want to find its acceleration, so I'm just going to put a question mark next to that. Okay, so the first thing I would do then, we're going to try and find s. So let's use s equals a half u plus v times t, and then just sub in what we know. So we're going to have half 20 plus 50 times 10. Okay, and working this out, you can obviously use a calculator if you like, but this just gives us 350 meters. Okay, so we found s now, so that's the distance it traveled. It traveled 350 meters. We now need to work out the acceleration. Now, of course, you do now know another variable. You know that the displacement, but I prefer to imagine that we don't know that and then just find acceleration without it, just in case we make an error in this question. That means we would then make an error in the next one. So if we do it without it, we hopefully won't make a second error if there was one in the first place. So now we need to find a. How can we do that? Well, I would use v equals u plus at. Okay, so we've got v there, we've got u, we want a, and we have t. So subbing in what we know, we're going to have 50 equals u, which is 20, plus a that we don't know, times 10, so 10a. Linear equation here should be relatively easy to solve, so we'll have 30 equals 10a, then a must be 3. What units will it be? Well, we're working in SI units, so this will be meters per second squared. So we found the displacement, we found the acceleration, we're done. Okay, so Danielle jumps from a diving board that's 10 meters above the pool. If her initial velocity is upwards 1 meters per second, how long does it take her to reach the water, and what is her velocity at this point? Assuming that g equals 10 meters per second squared. So a good thing to note there is that is a little bit different than we would normally do. Normally we'd use 9.8, but because the question has explicitly said 10, we'll use that. So let's first write down the variables. So let's take s is 10 meters. Let's take u. Well, do we know? Yep, straight upwards 1 meters per second. Okay. An issue we could have here is the fact that this is actually downwards, because the diving, if we imagine there's the pool, the diving board's here, we know that this distance is 10, and this is actually going upwards, so we need to be careful we're being consistent with direction. If we're taking downwards, because that's the resulting direction, as positive, so downwards is positive, then we need to actually make this negative, because it's going in the opposite direction. Okay, so carrying on from there, v, what is the velocity at this point? Well, we don't know it yet then. So a, do we know the acceleration? Yeah, she's accelerating towards the ground at 10 meters per second squared, because that's what it says for gravity. There's no other forces acting on her. And then t, we don't know yet. We're trying to find that. Okay, so it doesn't really matter which one you want to find first. I'm going to opt to choose, let's go for t first. So let's use, well, we've got s, we've got u, we've got a, we've got t. So let's say s equals ut plus a half at squared. So we're going to say 10 equals minus 1 t plus a half at, so half of 10 is 5, so 5t squared. Okay, just see where I've got that from. The 5, of course, coming from halving 10 there. So 10 equals minus 1t plus 5t squared. Let's rearrange this a little bit and we'll get a normal quadratic. So we'll have 5t squared minus t minus 10, and that's going to be equal to 0. Now, you've got a quadratic to solve. You will actually get 2 answers, but we're going to discount the negative answer because we don't like negative time. So let's take t equals 1.52 seconds. The reason in this case that we don't like negative time, if the answer was negative, well, that's implying that she's hit the water before she's even jumped, which doesn't make any sense at all, does it? So let's just take the positive answer. So 1.52 seconds, that's rounded to 2 decimal places. So we found t. We just need to find v now. So there's a couple of ways that we could do this. I'm going to opt to not use t just in case we've made an error. It's sort of a little insurance policy. If we'd made an error finding t, then of course we'd get v wrong. So let's not use it, and instead we'll use v squared equals u squared plus 2as. Sub in the variables that we know. Well, we don't know v yet. We know that u is -1. That squared is going to be +1. Plus 2 lots of a, so 20, times s, which is 10, so plus 200. Okay, so then v squared will equal 201. Then we'd have to square root that because we want just v. So v equals 201 square rooted, and that will give you 14.18 meters per second. And again, there'll be 2 roots of this. We're not going to take the negative one because remember, at first we took downwards as positive. So if we took the negative one, that implies she's going upwards. Well, if she's hitting the water, she's definitely not going upwards. So we'll take the positive value there. So 14.18 meters per second. And again, that's rounded to 2 decimal places.